Hello and welcome to section 12 or 13.4, which is on compound probability. A compound event is an event that is made up of two or more events. Independent events, when the occurrence of an event does not affect how another event occurs. And dependent events are the ones where the occurrence of an event does affect how another event occurs. So in my example here, if you roll a dice and then flip a coin, are these events dependent or independent? Well, let's see. Does it matter what I roll on the dice? Is that going to change how I flip my coin? That's what you need to ask yourself. And the answer should be no, it is not going to affect it, and therefore your answer should be it is independent, because the roll of the dice does not affect the flip of the coin. They have nothing to do with each other. Okay? Two things that would affect each other. Let's say that I had a bunch of coins in a jar, and if I pull, let's say I had just dimes and pennies, and obviously I know you can feel the difference between them, but let's just say that I'm going to pick two coins and I'm not going to replace the first one. Okay, so if I pull a dime out, for my second turn I now have one less dime and one less coin, so your second probability is affected by the first one. That would be the difference between independent and dependent. So if A and B are independent, here's how you do it. Probability of A and B happening, A and then B, okay? Like I said, getting a dime and then picking another dime or whatever. You take the probability of it happening the first time, and you take it times the probability of it happening the second time. Okay, so let's just say, just to make it an easy example, let's say I had 10 coins, 5 were dimes, 5 were pennies, okay? The probability of me picking a dime the first time is a 1 in 10 chance, 1 out of 10 coins, okay? The second time, or excuse me, should be 5 out of 10. The second time, now I have a dime and I didn't put it back in there. So now I have 4 dimes and 9 coins, okay? So it is affected. Had I put that dime back in there, it would be 5 out of 10 times 5 out of 10. So you can see how it's affected there. And I could reduce this to make it easier on myself, right? So it would be a 2 in 9 chance of getting a dime and then getting another dime, okay? So my next example, you roll a dice and you spin a spinner that has 4 equal sections. What is the probability that you roll a number less than 3 and spin any one section? Okay, they're not saying which section, just a section, and they're all equal, so it doesn't really matter. So I roll a dice. What is the chance I'm going to roll a number less than 3? Well, that would only be a 2 and a 1 that would count, right? So 2 out of 6, so I'm just going to go ahead and reduce it to 1 out of 3 chance of getting a number less than 3, and any chance that I would spin any one section, and since they're all equal, it would just be a 1 in 4. I can multiply those two together, and it's just a 1 in 12 shot of both of those things happening, okay? Mutually exclusive. Those are events that cannot happen at the same time. You can't both rain and not rain at the same place at the same time, okay? So they're just two things that can't happen at the same time. So if A and B are mutually exclusive events, then the probability of A and B happening is 0, because they can't happen at the same time. The probability of A or B happening, you take the probability of A and add it to the probability of B. You add them together. Find them separately and then add them together. Overlapping events have outcomes in common, okay? So if A and B are overlapping events, then the probability of A or B happening is the probability of A plus the probability of B minus the probability of them both happening, okay? An example that I could think here, let's say I'm rolling a dice and I want to know what the probability is of getting an even number and getting a 4. Okay, there's overlapping things there because 4 is even, right? So the probability of A or B happening, the probability of A happening, an even number, is a 1 out of 2 shot. Probability of B happening is a 1 in 6 shot, and that shouldn't have been a times, it should be a plus, okay? So I'm going to add those two together and then subtract the probability of both A and B happening. Okay, so I mean that one's a little hard to do just making it up, but you get the point there, where you have to find them separately. You're going to add them together and then subtract the probability that they would both happen. Okay, so my next example here, in the spring season, 15% of the athletes play baseball and 23% are on the track team. It's not saying any of them play both, so we're not thinking about that, even though some may play both. What is the probability of an athlete either playing baseball or being on the track team? Okay, so in this case, you would consider these to be mutually exclusive, okay? Because it's not saying anything about them being on the same team. So you would very simply just take the 15 plus the 23, and you would get, there's a 38% chance of an athlete either playing baseball or being on the track team, okay? If they had said, you know, 5% are on both, then you would have to consider that, but it doesn't say that, okay? So what is the probability of rolling either an odd number or a number less than 4 when you're rolling a regular dice? Okay, so this is an example of the overlapping events. It says, what is the probability of rolling either an odd number or a number less than 4 when rolling a regular dice? Okay, well, what's the probability of rolling an odd number? You have a 1 in 2 chance, right? What is the probability of rolling a number less than 4? Well, that would be 3, 2, and 1, so it would be half again. What is the probability then of rolling a number that is odd and less than 4? Well, it would be a 1 and a 3, right? So you'd have to subtract that 1/3 chance from that. So 1/2 plus 1/2 would be 1, right? And 1 minus 1/3 would equal 2/3. So you would have a 2 in 3 chance of rolling either an odd number or a number less than 4, okay, when you're rolling a regular dice. A 2 in 3 shot. So that one was an overlapping event. This one was a mutually exclusive event. Okay, those are two separate things. So keep all those terms in mind and bring that knowledge with you the next time I see you. Have a good night.